The biggest benefit is we don't need those humongous QA teams anymore. So I think that's a big advantage, especially for startups, right? For smaller companies, I mean, that's one advantage. But you just need fewer people who are doing things. You're using automation to save headcount. So you're putting in a little bit more effort right now, but you're saving much more time and energy that would be spent otherwise if you wouldn't put in the effort into automation. How do you start is if your team is not already doing it, the first thing is get your team onboarded with, this is going to be a different concept where the developers are not just responsible for building the software and only the unit tests, but they're also responsible for building functional and system tests as well. And automating every test that they write, they have to be able to automate it. And once they automate it, then there are many technologies that are available. And over there, it becomes a complex matrix of which one you pick to build your DevOps pipeline or your CI/CD pipeline. It really depends on your use cases. If you are based on a private data center and that is your key, all of your workloads are over there, then you'll have to pick a system that is based on Jenkins or something else that you could actually roll your own. And there are also some other companies that are doing it. Acronyms, I have no idea who does what. But essentially at the core of it, you have some people who are owning the infrastructure which runs applications. So there is definitely a job family that caters for that. They are called cloud engineers if everything is on the cloud. They're called infrastructure engineers if you're doing some sort of an on-prem deployment as well. That's one piece of it. DevOps, I think, is a concept. So every developer should be a DevOps engineer. I don't think there should be a separate, at least philosophically, I don't think there should be a separate job category even saying DevOps. DevOps is a concept. If you're writing code, you're writing an application, you need to own testing it and running it in production as well. So for me, that's a concept, but I know that that's become a job family as well. For me, it's a concept. So I would say where you would start is if you're really starting your journey, I would just not try to roll your own and maybe use a cloud-based solution because it's just easier. There's a lot of information and help that is available and help you get familiarized with the concepts and setting something up pretty quickly. So either use a SaaS product already, that can just point and click and do things, or just use the cloud's native environments for CI/CD. That'll be the easiest and fastest way for you to ramp up. The mental models that you built as an outcome of that effort would be portable. So if you want to do a DIY private data center on-prem solution, the mental models are still the same. The abstractions are still the same. The technologies might be a little bit different. Depends on your use case. Where's your workload situated, right? So you gotta bring the CS system that works for your workload, right? So I would start off with your use case and your workload. And many organizations today have a hybrid workload. Some sitting in on-prem systems and some of them sitting in the public cloud. Some of them are really in one cloud, some of them are in multiple clouds. So I think it really depends on what your use case is. If you do have hybrid environments, then it just makes sense for using something that is more SaaSified, either from a native cloud or a SaaS company that can connect all of those dots together. If you're all on-prem, it'll be cheaper for you to roll your own using Jenkins and a CD system there's a lot of automation that's been built on top of Jenkins to continuously deploy to your environments. Cloud is more expensive, so it depends on how much money you've raised. Okay. So if you raise enough money, I would say that's the fastest, cheapest in terms of people that are going to have to work on setting it up. So taking something from the public cloud is going to be the fastest way to ramp yourself up. It's going to be probably a little bit more expensive, but generally that is what I would say is the easiest and fastest way to get bootstrapped. So infrastructure as code is just that you define it's an abstraction on top of the infrastructure that you're going to be using. And the beauty of putting everything in code, even every single infrastructure component that you have in code, is that now if you need to replicate it, it's very easy. It's not human driven, so there's no chance of fat fingering something. It just happens automatically. If you have breakages in your infrastructure, it comes back up through the same mechanism. So it's much more predictable, it's much more reliable because it's still machine driven. That's a fundamental concept that I think, again, DevOps is a concept, so I'm not going to go in there, but infrastructure engineers have almost all migrated towards managing all of their infrastructure through ISE rather than doing it through content. ISE is very widely adopted. So ISE does not come like the friction that exists, somebody losing the job, the queue of function disappearing does not exist in ISE. It's just solving a real problem, a real pain. So ISE is very, very widely adopted. People are using different technologies for it. If somebody's on AWS, they're using CDK or CloudFormation. Other people are using Puppet or Chef or Ansible. There are different technologies. People prefer different technologies, but the concept itself is very widely adopted because it's solving a key pain and it is removing misconfiguration from hitting production environments. Again, you gotta start off with where your workload is, and everything is dependent on that. This is a very deep question in terms of which ISE should you choose. So if you've got multiple options. If you're in the cloud, you could pick on AWS. AWS, you could take CDK or CloudFormation, which are both native, but CDK is the new generation. So I would just say go to the new generation and try to start up over there. Yeah, so I think there's a huge cultural change. I mean, that's probably the biggest part of this whole puzzle. I mean, like, it's not the technology piece. Technology is easy. People are hard. So that's where this needs to start. I'm like, if you can't get your people aligned around this will never happen. Or they'll just check some boxes and you really wouldn't have gotten the benefit, the business benefit, or the cultural benefits that you wanted to achieve from these kind of initiatives. So I would say, the earlier you start, the easier it is for you to build that culture. I would say the first person that you hire should be a very strong background and should have a very strong background in building things which have been built through automation, and developers owning their own codes all the way from building to testing to. There's a place for QA in the DevOps culture? No, there isn't. I'm like, wow, keep the purest view. You can ask me this question another time as well. I'll say the same thing. I don't think it exists. That traditional role of a QA engineer does not exist in the DevOps world. You have, like I said, you have infrastructure engineers who manage the physical or virtual infrastructure, got test infrastructure engineer who write infrastructure on which you can write your test cases in a very productive way. You have developers who are writing applications, they're writing their own test cases. You have site reliability, or more sort of like cross-cutting engineers who are actually looking at all the infrastructure and all the applications of them being healthy. But the fundamental job of this piece of code is going into production, and it's not breaking the application, and it's healthy, and it's not degrading its performance. Now must reside with the developer who wrote that code. Everybody else is supposed to provide abstractions and simplicity so that they can do the job more productively. So DevOps has made it faster. I can say that possibly, but the human mindset hasn't shifted. So there are two things over there. First of all, the developer's mindset hasn't shifted as quickly as how the technology has shifted from underneath them. So that's one aspect of it. The second thing is this has gotten almost next to no attention from universities. So students who are graduating absolutely have no idea what this means. Before they hit the industry, they have never heard these terms. They don't know what this means, and this is their first exposure to how to do really production grade software development. I think those are the gaps that are growth is slow. If you're not able to reskill existing developers, and if you're not getting people who know this upfront, that's the gap. This does not require a superhuman person. These are not really hard. It's not like learning a new language even. Most of these are like, I was saying, that all of ISC is generally in a YAML. It's just in YAML files. It's just config files. You're not even writing code. You're writing configuration. Like I said, you're opening a text file and writing configuration. I'm like, so it's really gotten the abstraction has gotten so good that it's become as simple as writing text in a configuration file many of the times. So it is not really that the technology is hard and you need superhumans to do this. It's just that the fundamental foundation where some universities are actually teaching it and getting people ready to join this workforce has not existed. And engineers who have developed in the legacy way, where they were relying on somebody else to do QA, are too lazy to go learn something new, or not even too lazy. It's sometimes there's just too much deluge of information and they get lost in it. And sure, I would say start early. So it's just easiest to do this early, and then everybody else just adopts the culture rather than trying to change the culture later on. So even if it takes a little bit longer to roll out the first few releases, just putting in the effort to build your IAC properly and setting up your test infrastructure as well as your applications to be built with this culture and philosophy is going to be a worthwhile investment. So start early. The second feedback would be very clear about your metrics on which you are actually going to be measuring success, as well as metrics through which you will actually determine that your applications are getting deployed more safely and faster. So the productivity as well as the availability, you need to find out what metrics would actually would quantify success for you. And the third thing is culture. Like as you grow and the cost of success is that culture actually starts corroding around the edges. Just keep that in mind. This is not something that you do. It's not a one and done thing. It's not like a fire and forget thing. This is something that you need to continuously bring back, because if you let it lose, you don't keep it tightly contained with the right metrics, with the right ownership models, you would run into situations where you started off on a good foot, but then it can actually regress into the old way of doing things. So keep an eye out for those kind of cultural regressions as well.
DevSecOps is just a subset of DevOps. People do tend to separate these things out in saying that DevOps is purely just CI/CD and infrastructure as code that just allows you to rapidly develop applications and deploy them. DevSecOps, on the other hand, is where people say that your automated security testing is built into the pipelines themselves, right? So it's development and security operations. So it's sort of decoupling the application, continuous integration and deployment with additional guardrails that essentially just perform security specific functions. Like static source code analysis is an example of DevSecOps, right? Or configuration management in terms of analyzing what is your configuration of your infrastructure as code. That also comes under DevSecOps. But in my mind, DevSecOps is just a subset of DevOps. A right DevOps pipeline has to have security built in. It can't be an afterthought. So that's at a higher level, right? So DevSecOps directly targets the security specific things in a DevOps pipeline, and DevOps pipeline is essentially just the applications continuous integration and deployment.
MLOps is basically DevOps meeting machine learning. You have all the nice parts of the DevOps pipeline: CI/CD, deployment, dependable releases, monitoring, and basically what DevOps has done for developers, where they develop the software and then give it to the IT team, and the DevOps team to eventually deploy, monitor in production, load testing and all of that. MLOps is that plus some machine learning components to it. And most of the differences between MLOps and DevOps, it contains of 5 different parts, roughly. Number one, team skills. So in MLOps, your team is structured differently than in DevOps. Now you have data scientists in the mix. And these are folks that don't have necessarily software engineering knowledge, but they're very machine learning focused and algorithm focused. So the team structure is a bit different in MLOps. Another is experimental development. So in traditional software development, it's roughly linear in some sense, but in ML pipelines, it's kind of circular. There's a lot of iterating, there's a lot of trial and error in getting the best model for your problem. So the pipeline is a bit circular. There's additional testing needed. In addition to your normal integration and unit testing, you want to do some data testing and model testing. Then you also have deployment. So you want to be able to deploy really fast, but you also want to be able to rerun the deployment based on signals that you see in production. When you're monitoring your model in production, there might be signals where you want to retrain your model because your model is moving away from what it's supposed to be doing. So there's like this feedback loop in deployment that also needs to be done in MLOps. And then you also have monitoring. So you're monitoring for extra metrics now, in addition to the normal software health and traffic and memory and all that. You have extra metrics to monitor for machine learning. That could be prediction quality and model performance and things like that.